Okay, in this problem, we're going to look at the normal distribution. Wingfoot is a tire company, and it wants to warranty its tires. And in order to do this, it randomly samples each model and size of manufacturers. It places each sample tire in a machine that will roll the tire under normal load until it has 2/32 inches of tread left. The statistics on this particular tire are as follows. It has a mean of 73,100. It has a standard deviation of 2,800 miles. The skew is pretty close to zero. The kurtosis is pretty close to zero. About 68% of the tires within one standard deviation, about 95% within two standard deviations, and nearly all are within three standard deviations. Now, this information right here suggests the data is normally distributed because the skew is close to zero, kurtosis is close to zero, and this right here is the empirical rule, right? About 68% are within one standard deviation, about 95% are within two standard deviations, and nearly all are within three standard deviations, right? So what we're saying here is the empirical rule is satisfied. The distribution is pretty symmetric, and the top of the distribution is rounded, right? It's not pointed or flat. Okay. Assuming the population mean and standard deviation are equal to the sample mean and sample standard deviation, we're going to compute the following answers using Excel's norm.dist and norm inverse functions. Then we're going to verify these answers using statdistributions.com. Okay, the first question is we want to know the 90th percentile. And I've already, let me change this to 73,000. Let me change this to 73,100. And let me change the standard deviation to 2,800. Okay, both of these are in miles. Okay. Now, this very first question, what is the 90th percentile for this tire? We want to know the 90th percentile, right? We know the 90th percentile. So the question we want to answer is this one here. We want to know the number, right? The number on the horizontal axis, such that the probability of being less than that number is 0.90. So this is the left tail probability. If I open up stats distributions calculator, the way you set up the 90th percentile is you want the left tail of the distribution. And you can set this to 0.90. Okay. So for a standard normal variable with a mean of 0 and a standard deviation of 1, 90% of the observations are going to be less than 1.282. But we don't have a standard normal distribution. We have a normal distribution with a mean of 73,100 and a standard deviation equal to 2,800. So this is visually what a 90th percentile is. This area is the probability, and it goes from negative infinity to, looks like 76,689 or 88. We don't really know what that is because we don't know what the next decimal place is right here. That's 0.445, or if it's 0.495, or if it's 0.513, right? We don't really know what that is yet. So that's why we're going to use Excel. Okay, so this is what it looks like graphically. We want to know the number down here, the number on the number line, the miles, where the probability of being less than that is 90%. So the way we do that in Excel is we're going to use equal norm.dist or norm.inverse. Okay, so let's just type equal norm.dist. Now notice that Excel is asking for a value on the x-axis. And what I'm given here is a percentage, a probability. So I don't want to use dist. I want to use this when I'm given miles in this particular problem. I want to use dot inverse. And norm.inverse wants the probability value fed in. And the probability value is 0.9 or 90%, right? And then I need the mean, which is in cell B1. And I need the standard deviation, which is in cell B2. And then I can just hit enter after I close the parentheses. And I get 76,688 miles. Now, notice here, I've named, this cell is named A1, right? Because it's in column A, row 1. This is in cell A2 because it's in column A, row 2, right? But notice right here, this is named B or M. So I just named it M by replacing B1 with M, hitting enter. And I've replaced this name, B2, with the letter S by just typing S and hitting enter. Okay, so that helps me out quite a bit because I can come down here and I can just name, instead of using B1, I can use M or the mean. And I can use S for the standard deviation. And I get the same number. Okay. So this, the inputs to this are a percentage or a probability, the mean, and then the standard deviation. Stats distribution does the same thing, right? We entered a probability. Let me blow it up for you. We entered a probability, we entered a mean, and we entered a standard deviation, and out came the 90th percentile. The value of miles such that the probability of being less than it is 90%. Okay, so when we hit enter, we actually get, let's increase the number of decimal places here. So statdistributions.com isn't very precise, but it gets us close enough, right? So you don't want to use the numbers from statdistributions.com. You want to use the values from Excel. Excel is more precise. So let me copy this number, and we're going to paste it right here. And we'll check to make sure we got their answer right. And we got the answer right, correct? Okay. So what we were looking for is we were looking for the number that makes this equation true, right? We're given the probability, and we want to know the number that makes this equation true. And the answer here is in red, in this red font, in this yellow box. Okay, the next question is the 10th percentile, right? In statsdistributions.com, to get the 10th percentile, all we got to do is change 0.90 to 10. So we're inputting a probability value, the mean, and the standard deviation, right? We're going to do that again with norm.inverse. And we want to use inverse because we want to feed it the probability value, just 10%. And then the mean, which in our case is 73,100. And then standard deviation, which in my case is 2,800. Okay, and I'm using M and S for the mean and standard deviation. And I close parentheses, and I get something pretty close to what statsdistributioncalculator.com gives, right? I want to use this number because it's more precise. This gives us a nice visualization. We want to use the numbers from Excel. Okay, We got those two, right? Now we want to know what is the probability the randomly selected tire will wear out before it reaches 1,512 miles. Okay, I'm going to put that right here. Oh, by the way, I'm gonna pull the question down here. I'm gonna change this into an equation for the question. Okay, now we want to know what this is, right? So we're looking for the question mark here. We want to know the value such that this equation is true. So the probability of this number, the answer, the probability of being less than this is 10%. Okay, now we need to know what the question is here. We want to know what we want to answer the question. What is the probability that a randomly selected tire will wear out, will last fewer? That's less than 71,512 miles. So I'm going to copy this. I'm going to change the question mark to the blue. I want to know the question mark here. And then red is part of the question, right? In this case, 71512. Now the question has changed, right? I'm giving you the miles, and I want to know the probability that the tire will wear out before it gets to 1,512 miles. Okay, that's another way to state the problem there. So here, I'm given the miles. I'm given a value on the x-axis. So I want to use norm.dist. Why? Because norm.dist asks me for the value on the x-axis, right? It says input the value on the x-axis. In this case, 71,512. And then it asks me for the mean. To enter the mean, I'm going to type M. And then it's going to ask me for the S. And then I need to say true because we want the cumulative distribution. And I get a probability of 0.2853. Okay, and we'll hit enter. And I'll verify it with stat distribution calculator. And now we're going to change the z value here, the value on the horizontal axis, to 71512. And I do get a probability of 0.285. See, this is not accurate enough. It's only 3 decimal places. That's why we need to use Excel, because I'm asking for 4 decimal places, right? Okay, now we want to know what the probability that we want to know the probability that a randomly selected tire will last longer than 76,712 miles. So I'm going to copy this. To here, right? Whoops. Okay. Now I'm going to change the question over here. I need a probability, but I'm going to change this to greater than 76,712. Okay. And in statdistributions.com calculator, I can do that by just clicking on the right tail, flipping it, right? And then up here, I can just type in 76,712. And so the probability is going to be close to 0.099, right? I want this probability, right? Now what Excel gives you the white area, right? Excel gives you the white area. So this probability is equal to 1 minus okay, these two probabilities are the same, right? This right here is the blue area. This right here is the white area. So if the blue area is 0.099 or really close to 0.1, this is going to be really close to 0.9, right? And remember, 1 minus 0.9 is 0.1, right? So these two things are the same. I'm going to move this up here. Okay. So the first thing I'm going to do is I'm going to calculate this probability. I'm going to calculate. So I want this probability right here, right? Well, let's just do this. Equal norm dot dist. We use norm dot dist because we're given a value on the horizontal axis, right? We have this value x. We have a value on the horizontal axis, so we need to use norm dot dist. And I'm going to click this, right? And I'm going to type comma, and then m is my mean, right? It's my mean up here, comma s, and then I had to finish it off with true, right? True. Now this is going to give me a large probability. Why? Because this is the cumulative probability, the left tail probability. And it's going to be large because this number here is bigger than the mean. Right? But I want a number that is small. Right? I don't want the big number to the left. I want the littler number to the right. So the way I do that, I just type a -1 or a minus in front of norm.dist. Okay. So now this will give me the probability to the right, which is 0.0985, right? This isn't accurate enough. So I'm gonna use this in my answer, right? Okay, got all those correct. Now we need to know what is the probability that a randomly selected tire will last between these two tire mileages, right? I'm gonna do the work right here. I'm gonna do the work right here. Okay, so the first thing I do is I got to copy this number. I'm gonna copy the bigger number of miles on top, and the smaller number of miles on the bottom, below it. Okay, now what I'm doing is I want to find this probability. This is my goal now, right? I want to find the probability that I'm between 74,012, right? I want to find the probability that the tire mileage, a randomly chosen tire, is between this number, between 74,012 and 7,512. Right? The way you calculate that is calculate these two numbers. Well, let's see. Oh, I gotta get this. I gotta fix this right here. This is the bigger number, 9712. So this is that number, and this is that number. So I want the probability that the tire wear for this randomly drawn tire is between these two numbers. So the way we're going to do that is we're going to copy this. We're going to first get this probability value. And then we're going to get this probability value. So 74012. I want to get these two probability values. And the answer to this is the difference in these two. Okay, the difference in these two, right? Let's go to statdistributions.com to figure it out, to visualize it, right? So I got to change this to left tail, right? I got to change it to left tail. And I got to change this to the bigger value, 79712. See that? So the probability of being less than this number is 0.991. And I'm going to type it in here temporarily. Just type it in there temporarily, right? This is not the correct answer, right? Now, what's the probability of being less than this, right? 74012. Okay, the probability of being less than this number is 0.628. And these are their incorrect responses so far. I'm just kind of showing you. And the correct answer is going to be difference in these two. Why did I say it's the difference? Because what we want is the probability. Let me put in a line here. Nope. Okay, where's my drawing tool at? Let me get my drawing tool. They change Zoom because I used to be able to. Okay, I guess what we'll do is this. Just draw it freehand. 79, which is right about here, right? I want to know what this probability is. Question mark. Right? Right? So I want to know the white probability. I don't want the green probability, and I don't want the blue probability. I want the white probability. So this white area plus this purple area is this 0.9910. The blue area is 0.6280. So the white area is the difference between this from here to negative infinity and from here to negative infinity. So I got to subtract the 0.6280 from the 0.9910, right? That's what I'm doing. I wonder what happened to the tools here. Yeah, you used to be able to pull up a toolbox. Okay. All right, so we're going to calculate this here. Instead of using the numbers from statdistributions.com, we're going to type norm dist, and then we're using norm.dist because it's calling for a value along the x-axis, which is that. Then we have the mean m that we named m, the standard deviation we named s, and then true, right? And then what I'm going to do is I'm just going to drag this down. So this number is close to what stat distribution comes up with, 79712. It's close, right? 0.991. It's close. This number is close to what statdistribution.com comes up with. Right? to 3 decimal places, it is the same thing, right? So again, the white area here, the white area is 0.3632. I copy that into here. Now we want to know what is the probability that a randomly selected tire will last between 71,512 and 76,712 miles, right? So I'm just going to copy this down and paste it right here. And I'm just going to change this to 76,712. I'm going to change this to 71,512. Okay. So let's verify in stat distribution calculator. All right. So the first number, 76,712, right? So this, right, this blue area is 0.901. So I need to shade this here, right? I don't want this area anymore. So I need to subtract from this value here, 0.901. What do I need to subtract from it? $715.12. Okay. So I want this area here. I don't want the area over here, right? I don't want this area. So the white area plus the blue area is 0.9015. And I got to subtract this off of it, right? And so this white area here, in between the green area and the blue or purple area, this white area is 0.6162. Yep. Now, the last thing I need to do is I need to answer this question. I wish I could erase that. Unlike the range of the data, it contains all the data, 100% of the data. So the range is the maximum minus the minimum, and all the data are between the max and the minimum, right? Are between, which implies inclusion, right? So max is in the data, the minimum is in the data. So 100% of the data are between the min and the max. The interquartile range, on the other hand, contains the middle 50% of the data. So I need to change this to the middle 50% of the data. It contains the middle. It doesn't contain the lower 25%. It doesn't contain the upper 25%. It contains the middle 25%. So the interquartile range, to find the interquartile range, the lower value and the upper value is 2, 3, the third quartile. The lower value of the interquartile range, minimum of the interquartile range, is the first quartile. Because the first quartile is the 25th percentile. Third quartile is the 75th percentile. And 75 minus 25 is 50, specifically the middle 50% of the data. So all we have to do here is, I'm giving you the probability value, right? I'm giving you the probability value. So let me copy these up here. I'm going to change this to 75. I'm going to change this to 25. Okay. So the third quartile is the 75th percentile. The first quartile is the 25th percentile, right? So I've given you the probability value. You have to give me the miles. So we need to use equal norm inverse, right? You feed norm dot inverse a probability value, in this case, 75%. And then we have the mean, which we've named M, right? M, mean. And then comma S, which is the name for the standard deviation. Okay. And then all we have to do is hit enter. Then I'm going to drag this down, right? So now we're feeding 25% as a probability into here, right? With the mean and the standard deviation given above, right? So the interquartile range, 50%, the middle 50% of the data are between 74,189 miles and 71,211 miles. Okay? So this is 749, 740,989. And whoops, I need to put the little number there. The big number goes on the left. 74,989. And it changes to the lower number, 71,211. Okay. And then we'll verify that with statdistributions.com, right? So I can make this 0.75. So the 75th percentile is 74,989, right? I can copy this number and I can paste it right here. Right? So if I put in this value on the horizontal axis, 74,989, the probability of being less than it is 0.75, right? If I copy this number here and put it into here, I get 25%, right? So the middle 50% of the data is between 71,211 and 74,989. Okay, the last thing we have to do is explain why the tire company believes this wear on the model and tire size has a normal distribution. You're contemplating whether the tire warranty should be. Okay, so first thing we want to do is we want to talk about normal distribution. The normal distribution. Again, remember what we said. The skew is close to zero. The kurtosis is pretty close to zero. And 68% of the sampled tires are within one standard deviation. About 95% are within two standard deviations. And nearly all are within three standard deviations. This is the empirical rule. And a normally distributed data follow the empirical rule. So we got 3 check marks there. That's probably close enough to zero, and that's probably close enough to zero. So we conclude the distribution is probably normal, right? Now you're contemplating what the tire's warranty should be, and are considered the 90th percentile and the 10th percentiles, right? Okay, so if you pick the 90th percentile, right? If you pick this as your mileage warranty, right? And your customers buy your tires from you and they treat the tires fairly, they have them properly inflated, they rotate and balance them, they don't have any alignment issues, they don't have any suspension issues. If that's your mileage warranty, you're going to end up warrantying 90% of your tires. So you definitely don't want to choose the 90th percentile as your mileage warranty. You want to choose the 10th percentile, right? So we're going to pick 10th percentile. And then, and we just justified it, right? So your company sets the mileage warranty at, well, the company's going to, if this is the 10th percentile, we're going to set our mileage warranty at that. But we're probably going to make it a nice number. We're probably going to make it 69,000 or maybe 70,000, right? Probably going to make it 70,000. If we make it 70,000, I'm just going to change this real quick, 70,000.